So guys, in this lab, we are going to mount an Elastic file system storage, and we will access an Amazon Elastic Compute Cloud, Amazon EC2 instance that runs Amazon Linux in order to mount that file system to our EC2, and we will examine and monitor the performance of that file system. So the first thing I want to do is to create a security group. So I'm going to go to my VPCs. And from the VPC, I want to go to the security groups, and I will create a security group. I will call this security group Elastic File System SG. Now, in this security group, I want to open any EC2 instance to be able to access my Elastic File System. So all these Elastic File System clients will be allowed to access my Elastic file system. Now in the VPC, I will choose the lab VPC that we normally create in previous classes. In the add rule, now in that custom TCP, I will select a type of the rule that I want to open is the network file system. So whether you search for it by typing NFS, which is port 2049. And now in the source, I want to use a custom source because I want to use a specific security group. Now this is what we call a security group chaining, where we chain multiple layers in order to add extra layer of security among those machines. Now I was supposed here to select the Elastic file system client. Now, why this security group? Pay attention to the security group ID. If you go back to or in a new tab, you open the EC2, you will find that there is an EC2 already launched. We launched it before as an Elastic file system client. It is a normal EC2 with Amazon Linux 2, so you could launch a new one if you want to try also mounting multiple EC2 instances to the same Elastic file system. Now this EC2 instance, it has a security group which is tagged as an Elastic file system client with the same ID of that security group. So if I go back now to my Elastic file system, I want to make sure that only my EC2 instance with this security group can access the Elastic file system. And now I want to create a security group. In the next task, we will go to create an Elastic file system. So we will go now to services or to the search bar, go Elastic file system to access the Elastic file system management console. So I will show you Elastic file system 2. This is lab VPC. Now we will go to customize, regional. You disable automated backup. You don't need to have a life cycle policy. Similar to SC3, you can move your data from Elastic file system intelligent tiering from standard to standard infrequent access. On the first access, we don't need any of that. So you can keep this to the default. The performance mode is general purpose. The throughput mode is bursting, which means the throughput scales with the file system size. You don't need a provisioned because the provisioned will give you an actual storage ready and the provisioned once the file system is created. And we don't want to enable the encryption. If you click next here, you can select the lab VPC. Now in that lab VPC, we have two subnets in two availability zone, one in 1A and one in 1B. The one with 1A is going to be the public subnet and the private subnet. Now, it is highly recommended that you always mount your Elastic file system to the private subnet to give it an extra layer of security. So we will select the private subnet 1 and the private subnet 2. Most students make mistake with that step here because they will keep the default security group, but this is not the security group I need to use. I need to use the security group which I just created, which allow access for my Elastic File System client. This is for my EC2 instance, so I don't need to select it to access my Elastic File System. So it will be the Elastic File System security group. And then I click on next. Now the policy here, you can also put an inline policy, but we don't have any specific inline policy to specify or a resource-based policy to specify with this Elastic File System. So I'm going to go next. And this will give me a summary of everything I have, and then I click on create. So pay attention, guys, to those steps and ignore this error if you receive this error by any chance. Are you copying that?
Yep.
Yeah.
Yep.
Now, in the next step, guys, we are going to go to the lab sheet. And from that lab sheet, we need to download the Vocarium key or the demo PIM file. If you do this from your root account, you can download the PIM file to your computer because we will access it and we will use it to access the EC2 instance via whether POTI or via the terminal in Linux and Mac. So what I want to do now is to navigate to my download folder where I copy and I put the PIM file for the EC2 instance, the Elastic File System client. I need to change the permission to 400 with lab users.pim. And the next thing, I need to go back to my EC2 instance. And in that EC2 instance, I need to copy the public DNS name or the public IP, which is easier for you to deal with. It will be okay. Let me go back to my terminal now, and I will do SSH -I, the name of the key, the PIM file, and this will be EC2 user. How I know that this EC2 instance will use EC2 user? It's very simple. If you go back to the details here, you will find that this machine using Amazon Linux machine as an AMI. So Amazon Linux 2 AMI, the username is EC2 user. If you have a Ubuntu machine, then the username will be Ubuntu. If you are using a different Linux operating system, then it will be a different username. And this will be at the public IP address of my EC2 instance. And then I will press in enter. I will verify that I want to access. And now I am inside the EC2 instance. So I have it ready here. If you go back to your Elastic File System, you will see that this Elastic File System is created. Now select that Elastic File System. You could see in the monitoring tab, will display some metrics about the Elastic File System, like the throughput utilization, the input-output operation per second, and the throughput by type as well. You could also look to the file system policy, the access point, if you have any access points created with it, and the networking as well, which means where you did mount this Elastic File System. Now, in the next step, guys, what we need to do is just after accessing the EC2 instance, we want to mount that Elastic File System to our EC2 instance. So the first step is I want to install in my EC2 instance the Amazon Elastic File System utility. Now, most operating system or EC2 instances will come with this tool pre-installed in it. But just to make sure that we have it, we put this command, sudo yum install -y Amazon Elastic File System utilities. Now, the next thing, I want to mount a new folder or a new directory in this EC2 instance where this basically will take and mount to it. We will mount the directory that will be linked and mounted to the Elastic File System. So I'm going to do a sudo make directory command, mkdir Elastic File System, I will call it. Now we need to get now the mounting command. The mounting command, if you go back to your Elastic File System page, in the attach, this will give you mounting via DNS or mounting via IP. Also, both commands should work. Now, what I'm going to use here is mounting via DNS. So you can use the mounting helper, or you can use the NFS client. In this particular scenario, I'm going to use or copy this command using this little icon here, which will help me to mount the Elastic File System to my Elastic File System client, and make sure that this name of the folder, because this is the folder that you should have in your EC2 to mount into it, make sure they are compatible or similar to each other. I have already an Elastic File System folder, which is basically what I need. The rest are going to be a command, sudo mount -t NFS4, so it will use file system NS4 and the file NFS server, the size, and also it will give the file system DNS name. So this is a public DNS name for this Elastic File System I just created.
Sorry, Basil, why are you using the NFS client instead of the mount helper? Just the reason for it.
Now, you could use the Elastic File System mount helper, but this is for TLS, when you have TLS enabled.
Okay.
Okay. And also in the lab, they are asking us to use the NFS client, because there is other ways how you can mount your Elastic File System to your EC2 instance. I will show you now. Okay, so now I copy the command. All I need to do is to press enter. This will take a few minutes, and it will mount now the Elastic File System. And I could verify this by putting the Linux command df-ht capital. With, of course, with sudo df-ht. And you can see now I have my file system already mounted. And I could see this because now I can see the public DNS name of the Elastic File System. Now let us examine this Elastic File System. We will examine the performance by running a simple command provided to us. And this command will basically take 5 to 10 minutes to complete. And this will create a file attesting images for our file system. And we will monitor the output of the FIO tool, because this will create multiple images as well. Now, what you can see here, that I basically use an FIO command, okay? And I'm writing this into my Elastic File System folder. Sorry. It's about 10 gigabytes. And this is will be going to the Elastic file system folder that I just created and mount to it. It will be the same from Windows. If you are using PuTTY for Windows, all you need to do is right-click for pasting those commands instead of just retyping them. Now we could go back to our our management console, and we will go to the CloudWatch, because in the CloudWatch we could monitor the performance of our file system. Because this command will take 10 minutes to finish, still in one process started. Now in CloudWatch, what we need to do is to go to all metrics tab. And from here, we want to choose Elastic File System. And then we select the file system metrics. And from here, you can see there is the file system ID. You could verify that this is the ID that you are looking for. As you can see here, I have two different IDs. So I need to verify that this is the same one. This is the one I am interested on, D08E. So I need to select that one, and you need in a specific permitted throughput to be selected with this file system. So I'm going to select this one here. And I should wait now for this graph to start to giving me some data. Now this will take a few minutes to basically show me better things, like I need to wait for 2 to 3 minutes in order to see a completed graph.
Basil, meanwhile, can I ask you a question?
Yeah, sure.
Why I'm not seeing the next one, data right in bytes in my list? I'm seeing only 7 metrics and it's 10 on yours.
Can you give me 2 more minutes and then I will ask you to share?
Yeah, no problem.
So I could change the graph type. I could zoom in and zoom out as well in CloudWatch. So this will give me the performance. I could go back and check as well the performance of my file system. So still I am in the first process, and I can see now in kilobyte how much data is in. We are about 68%. The estimated time is 1 minute and 12 seconds. The IOPS as well is 7 input output per second, which is not really bad. You could also add this untitled graph to your dashboard, so you can keep it and save it, and you can basically share it as well with your teams if needed. You can change it to numbers if you want. Maybe this is give you more better idea. And instead of selecting 3 hours, you can just select 1 hour. You could also choose a custom one. In custom, you could select, for example, 5 minutes. And in the same way, this will tell you and give you exact measurement of the file system. You could also select multiple metrics type related to the same one. If you select this guy here, you will find that this is containing nothing because I'm not writing into it anything. Let's take 30 seconds, for example. And as you can see, the value is 105, nearly about 105 throughput. So we will uncheck the primitive throughput now, and we will try to get more data. So we will go back to all metrics just to show you how I access this page. All metrics, and from file system, I am interested in a specific file system, which is this guy here. And I want to select now the data write IO bytes. You can search for it. Write IO in bytes. So I have it here, and you can see now I get the data that I'm looking for. I could select, for example, 15 minutes, and you can see it was nothing before. We just create it, we just mount it, and now it's a spike, and it's keep moving as well. We have also the graph metrics. And we want to collect the sum of the data write IO bytes. And in the period, we will choose 1 minute. And you can see we got like 6.2 gigabyte, because I think we are halfway to the process still. So as you can see, this will deliver like a baseline performance of 50 megabyte per second per terabyte of storage, and all the file system can burst up to 100 megabyte per second. Even if you have a file system which is larger than 1 terabyte, can burst up to 100 megabyte per second. And this is tell you how much the file system, the Elastic file system, is highly scalable and highly available with terabyte of storage scalability. So this is pretty much what we need to see in Elastic file system.